Hey kids, welcome to the last, and some might say worst, day of 15.3. All right, so we are still finding volume, but this time we are going to have to deal with the fact that maybe we're not dealing with a nice flat surface in our domain, right? So all of our previous problems, we have been able to draw either a rectangular region or we've been able to draw some other region, right? And take the domain, all the points from these places, and our function in two variables put us into the z plane and with some kind of surface above here, right? It's terrible, but you know what I mean, right? Right, and we built rectangles up from this flat surface, and we use the idea of Riemann and an infinite amount of those rectangular prisms or parallelepipeds, whatever you want to call them, found all their volumes, took the limit as the number of them went to infinity, did calculus to do that, and ended up with a volume. Well, what if the plane you're building up from isn't the XY plane? Kill me now. No, say it's not so. Please, biscuits, leave the plane down on flat on the XY axis. No. Sorry. So I'm going to lift this plane up, right? I'm going to say, well, maybe we have a plane up here, and maybe I have a plane here, and I want to find the volume in between, right? So again, that's a horrible representation. I do have a Geogebra site where you can go and look at this problem, where this is literally one of your homework problems, homework number 35, where I want you to find the volume enclosed by these parabolic cylinders. So if you want to see what this looks like and kind of play around with it, this is the Geogebra site you can click on. But I am dealing with two parabolas, right? If you think about these two parabolas, I have the red and the purple, and then I've got two planes. See this kind of gray plane and a yellow plane. And if you do go to the Geogebra site and kind of look at it, it kind of sort of looks like a paper towel roll that has been sliced, right? So these two parabolas, right? Those parabolic, they kind of create this cylinder thingy in here. That looks almost, like I said, like a paper towel roll. But the paper towel roll has these tilted planes, right? Slicing right through it. So the planes are your flat surfaces. This is flat surface 1, and this is flat surface 2. But flat, meaning, yes, they are, right? Well, they're planes, right? But they're tilted, right? So they don't lie down in the XY plane, right? So yes, they're flat, but they're not flat on the XY plane. So what the hee-haw are we going to do with this? What? So take a look at what you think this might mean. So remember I said I've got two planes. Those are my flat surfaces. They're just not flat on the floor or a wall or the ceiling. But one of them is on top of the other. So my integral needs to be, just like in Calc 1, right? Top minus bottom. So I have to be able to figure out who is my top plane. Well, let me rewrite these in terms of z, right? So I have z is equal to 2 minus x minus y. That's z1. z2, right? I'm going to move this z over to this side. And then I just have 2x plus 2y plus 10. So you can either try to visualize this or just plug in some points and figure out which one of these planes is on top of the other. And I hope it is not too challenging to see that the second plane is bigger. So Z2 is going to go here, and Z1 is going to go here. Notice I'm saying to myself, I wonder what I'm going to choose to be my limits of integration. But I want you to look at the values that I put already on the integrands. I'm sorry, on the integrals. Both of these equations were given to me in terms of y. And they would be a little bit, I could get them in terms of x, but why wouldn't I start there? And then where do you think -1 and 1 came from? Right? I have to see where are they going to meet. Just like I did before. So what do I have here? 2x squared is equal to 2. X squared is equal to 1. X is equal to plus and minus 1. So what does that tell you these are going to be? Since my constants are x values, this is going to be dx. And since my inside integral has functions y equals x stuff, this is going to be dy. And I'm not going to reverse that order of integration unless when I fill this in, I have an issue. There we go. Oh, my Lanta, right? Notice I did get z by itself first. So this is my top plane minus my bottom plane. And of course, I'm going to distribute and combine and get like terms, right? So that I have something nicer. (2x minus negative x is 3x). 2y minus negative y is 3y. 10 minus 2 is 8. And I'm going to integrate that with respect to y and replace then y with x squared minus 1 and 1 minus x squared. So when I integrate that with respect to y, who are your constants? Right? Constant, constant. So I'm going to get 3xy plus 3 halves y squared plus 8y. And for each one of those y's, I'm going to plug in x squared minus 1 and 1 minus x squared. Go. I will tell you what my answer is and then see if you get to the same place when we meet. Now, I didn't get 64 thirds right away, did I? I had to plug this in. I had to get a whole new equation and combine some like terms and add some fractions and all that kind of stuff. And then I had to integrate again I don't know why I had to write that. I had to integrate again with -1 and 1, right? And then I got my 60 when I did with respect to x, and that's when I get my 64 thirds. All right, good. See if you get what I get, and I'll see you in our live session.